Greetings and welcome, friends. We are taking a look at 5.7 solving systems of linear inequalities. So imagine if you had a line, but it was not necessarily equal to that line, but was everything less than that line. And then there was another line that could have been a solid line and was everything less than that. There is a common shaded region of which solutions to both of those lines equations, inequalities in this case, would exist. And so that's what we were talking about yesterday. It's just like, imagine if you did two problems in one problem is really the big idea. So here, this is just saying, tell whether the ordered pair is a solution. -4, 3. So -4 up 3, not a solution. And no. -3, -1, -3, -1. Well, it is in the common shaded region between both of those. So yes. By the way, this one was a solution of the first, or the solid line, but not the dashed one. So it's got to work for both. -2, 5 is actually a solution for neither. Yeah, so definitely not a solution for the system. And then 1, 1, I think, is a solution of just the solid one. My shading on this doesn't show up the best, but you got no. Why am I writing yes when I'm saying no? There we go. All right. It must have been my brain doing pattern recognition, which is actually something that, as you're learning math in general, even if you don't get it, just like keep at it, keep practicing problems, keep paying attention, because your brain will eventually just like recognize patterns is the way that it works. So so definitely do that. So here we go. Here's the first line. I'm going to check to see whether or not this point is a solution of it. That's an x and a y. I'll plug in those values. It looks like this one only has y. Is -1 greater than -2? That is true. True. Let's see. Pick up the pace, Mr. Waddy. Don't take too much time on these early ones. Plug in the -1 for the y. Is that greater than x, which is 1, minus 5? -1, is that greater than -4? It is. It is, right? I'd rather owe someone $1 than owe them $4. So this is a solution. Question, comment? Yeah, yes, yes. So yeah, you could think of the greater than symbol as being, yeah, on the number line. Is it to the right of? Greater than would be, yeah, is it to the right of? And so yeah, -1 is to the right of -4, so it's in the big direction rather than the small direction. Yep. Let's see. Oh, I'm pumped. I love 16. Here we go! Yeah! I only did one from this batch, but there were so many good problems that you had. Let's see. Let me rewrite this first one. This one's not in slope-intercept form. It is scary. It is scary. Was looking at you. So subtract x from both sides that have y is greater than the opposite of x plus 4. Now that's in slope-intercept form. The other one already was y is greater than or equal to 3/2 x minus 9. Tell you what, we'll write the slope in the y-intercept. Whoa. So the slope over there is 3/2. The slope here is -1, like a hobbit wearing a ring. It was invisible the whole time. And over here the y-intercept is the -9, and over here the y-intercept is 4. Now, what about the inequalities? What does this mean? What am I doing? That is not the color I selected. Solid and above, right? Solid because of the equal part, and above because y greater. Bigger for y is above because y is the vertical axis. Positive here, negative there. And how about this one? Where's this one going to be shaded? Above, and Yeah, dotted, dashed. I say both. So let's graph this the blue line first here. Blue line +4, a 1, 2, 3, 4, and a slope -1. Down 1 over 1. Down 1. Oh, I didn't plot the point. There we go. Down 1 over 1. Down 1 over 1. Down 1 over 1. And let's draw the line with my full start line drawing tool, like a weed whacker. My snowblower got a tune-up the other day. I'm ready for winter, I think. All right, there's that one. Oh, no, this is a dashed line. Dashed. My hopes were dashed. Let's see. I was able to erase it. If you guys make that mistake, just, point to it and write dashed, and I'll know what you mean. All right, so there's my dashed line, and this was shaded below. So let's see. Right, something like that. Oh, man. With the save, man, I'm making all the mistakes. You guys got to pay attention because, yeah, you never know. Don't just trust old Mr. Waddy. I might make a mistake. Did I change my setting on that? I feel like I did. I think, yeah, I feel like it, maybe. Yeah. Well, anyways, there's that inequality. All of the solutions that make it true are the points above the line, not including the line. This one had a y-intercept of -9. I had to change my graph. Yours is still too small. My apologies. But mine is... I'm trying to draw a point with the hashtags that I've got going on here. Here we go. There's a point. Got to use my pencil tool. Up 3 over 2. Oh, I love it. Finally to have a slope that's not just like up 1 over 2. Up 1... Right, here we go, up 3 over 2, and up 3 over 2, and up 3 over 2, up 3 over 2. This one's a solid line. I don't know, it's like my little pull start weed whacker. When I pull up this little circle of tools, right, like I've got to like that's how I open my ruler. Oh, I can also close my ruler that way. Let's see, is there a way, actually, what else do I have on my little, oh dear, what did I do? Yeah, and this one's shaded above. Let me select my hash marks here. So shaded above, shaded above. Da, 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 da. Right, Winnie the Pooh. And yeah, so we've got a lot of points. Oh, they wanted more than just a graph, is what you're saying? Yeah, they did. They did. Yeah, so the graph would look something like that. The solutions are then the common shaded region. Points on this line would work. Points on this line would not. And my solutions, yeah, are all in kind of this nice Aurora Borealis blue and purple, right? So there you go. It's just two graphs on top of each other. Slightly more interesting. Here we go. Let me shade this a little bit better just so it's more obvious what's going on. So I'll call this the purple, all right, for that dashed line. And for the blue line, it looks like it had to have been shaded below, right, in order for this to be the area that was the common region, right? So, so that's what we're looking at, something like, I don't know. Oh yeah, yes, yeah. This is not centered. Yep, which is fine. Sometimes you'll pan and zoom your axis as you need to. So let's see. Let's find the equation of the blue line. So if I want to find these equations, I've got to find their slopes and y-intercepts. Over 1 up 2 is a solution, but this is actually asking for what are the lines? What are the equations, or rather inequalities, that work? So let's find the slope of this blue line, which is solid. Well, I have to pick 2 points where it crosses the grid. Up 2 and over 1 would have been here, so that's less steep than that line. I think Austin's got it. Up 5 and over 1. So the way I found those was I picked 2 points where they were actually on the grid. So the slope was 5. And what was the y-intercept for that? 1. And for that line, it was a solid line, and it was shaded below, right? So let's see if I can combine this information into an inequality for my blue line. So it's y mx plus b, so y 5x plus 1. And as far as the inequality here, it's solid, so that means it's going to include an equal part. And it's shaded below, so I want a less than or equal. All right, so that's the inequality for the blue area. No, it's going up 5 and then run to the right. Run to the right. Let's see if we can do the same thing for the dashed line. So here, the y-intercept appears to be -2. And Austin, you're calling the slope? Yeah, it looks like for other points on the line, I've got some more options. Up 1 over 1, so my slope is 1. It's a dashed line, right? So it won't have the equal to part like that one did. And this one is shaded above, right? The purple was above it. Okay, so I'm expecting to write this inequality. Here we go, here we go. How am I doing for time? Yikes, all right. So I'll have y mx plus b, so 1x minus 2. And it's dashed, so won't have the equal part. It's shaded above, so that means greater than. So those would be my my two inequalities. Those would be the system right there. All right, so I have to kind of like pull in all of my old writing the equation of the line skills from chapter 3, but then also include, no, that's chapter 4, my bad. And then now we've added this extra piece of can I interpret these to be an inequality, right? So yeah, so I like that problem. All right, thanks for watching, internet friend. Bye.